Yes, good day, students. My name is Mr. Jibrin Isa. I'll be taking you discuss CHM122 General Inorganic Chemistry. The synopsis for this course is divided into two. I will be handling the first part of it, and you shall see the breakdown of the area I shall cover in due course. Then the content for the topic I'm going to be discussing. The topic I'm going to be discussing is Introduction to Inorganic Chemistry and the Periodic Table, and I will discuss this topic under the following: Introduction to Inorganic Chemistry, Periodic Table and the Periodic Law, Groups of the Periodic Table, Periods of the Periodic Table, Fundamental Properties of the Elements of the Periodic Table. Now let's begin. As Introduction to Inorganic Chemistry. Inorganic chemistry is an area of chemistry, is an aspect of chemistry that deals with the study of matter that are non-living. It also deals with the study of the synthesis and the behavior of inorganic and organometallic compounds. It deals with the study of mineral elements, inorganic compounds, and also organometallic compounds. This field covers chemical compounds that are not carbon-based. You will recall that organic chemistry deals with the chemistry of carbon compound. In this area, it deals with only inorganic substances that are not carbon-based. This particularly deals with mineral elements, inorganic compounds like mineral acids, bases, and also salts. It has application in every aspect of chemical industry, including catalysis, material science, pigments, surfactants, coating, medication, fuel, and in agriculture. Periodic table and the periodic law. One of the most important classification in chemistry is the arrangement of elements in the periodic table. Early classification began with some scientists, namely Lutomeyer and Anthony Lavoisier. They classify elements into their physical and chemical properties. Then later classification was done by Dmitry Mendeleev, who classified elements in increasing order of relative atomic mass. He discovered after classification there were some gaps in the table which you try to construct. So he predicted that there were some undiscovered elements, and he even predicted the properties of these elements. Then, because of the discovery of the electronic structure of the atom, he now discovered that arrangements of this element is no longer based on increasing atomic mass, rather in increasing atomic number, and this led to the modern periodic table, in which elements are arranged in this table in increasing order of what atomic numbers. The periodic table is built up systematically according to the regular distribution of electrons in the shells of the atom. The arrangement of elements in the periodic table makes things easier because knowing the physical and the chemical properties of these elements of one element in a particular group will enable you to predict the properties of other elements in the same group, because elements that are placed in the same group are placed there because they exhibit similar physical and chemical properties. Now, the periodic law. Remember, I did mention previously that the basic assumption behind the modern periodic table is the periodic law, and this law states that the properties of the elements are the periodic function of their atomic numbers. What do you mean by this? If you want to know the property of any element, you should know its atomic number. If you know the atomic number of any element, you'll be able to write the distribution or arrangement of what the electrons in the atoms of that in the atom of that element. If you arrange these electrons in the atoms of that element, you are going to know the number of valence electrons in the atom of that element. Knowing the number of valence electrons tells you the group that particular element belongs, and knowing the group, you'll be able to predict or even state conveniently the properties, both physical and chemical properties of that element. For example, we know group 1 elements do have 1 electrons in their atomos shell. As such, they can readily give out their electrons and they can behave like a metal, and you know the properties of the metals, which include high melting point, high boiling point, and so on and so forth. So knowing the electronic configuration of a particular element after knowing the atomic number, you'll be able to state the properties of that element conveniently as it is placed in the periodic table. Now, the groups of the elements in the periodic table. Now, the vertical columns consist of elements, and the vertical columns of the table is called the groups. Elements are placed in the same groups because they exhibit the same number of what? Valence electrons. What do you mean by valence electron? This is the electrons in the atomos shell of every element. For example, if an element is having a valence electrons of 2, it will be seen in group 2 of the periodic table. If the element has a valence electron of 3, it will be seen in group 3 in the periodic table. So the following are the groups that constitute the family of elements in the periodic table. The first group is group 1, which is called the alkaline metals. We have group 2, alkaline earth metals, group 3, the boron family, group 4, the carbon family, group 5, nitrogen family, group 6, oxygen family, group 7, the halogen, that is halogen family, then group 8 or group O, that is the noble gases. Basically, there are 8 groups of the periodic table. Group 8 is called group O because they show inactivity, that is, they show readiness to what? To combine with other atoms. That is, they are inert and they have valency of 0, and that is why they are called group O also. Groups of the periodic table continues. All elements in a particular group, like I did say, will have the same number of valence electrons. For example, group 1 have 1 electron in their atomos shell. Example of elements in group 1 include hydrogen is also here, lithium, sodium, potassium, rubidium, cesium, and francium. These elements constitute the first group. They have 1 electron in their atomos shell. These elements are very reactive, and as such they occur. They do not occur free in nature, rather in combination with other atoms as compounds. So because of their reactivity, they are usually stored under oil. And you can see they react readily with air and water. They have low melting points and boiling point and density compared to other metals in the periodic table. They are good conductors of heat and electricity. Now, group 1 and group 2 elements are known as S-block elements. Remember, periodic table is categorized into blocks. We have S block at the left hand side, we have P block at the right hand side. The middle, the center, contain the D block element. Then down below the table there are other 2 rows which constitute the F block elements. So elements are placed in a particular block because they does contain outer electrons occupying a particular orbital. For example, group 1 and group 2 elements are known as s block elements because their outer electrons occupy s orbital. If you are to write the electronic configuration of these elements that are in s block, you discover that their last orbital would be s orbital. Then also group 3 to 7 and also group O are categorized under p block element because their their outer electrons occupy p orbital. So like I said earlier, for s block, if you are to write the electronic configuration of this element, you discover that the outermost orbital will be p for group 3 to group what? O elements. Now transition elements, which are the d blocks element, they are elements with partially filled d orbital. They are placed in between group 2 and group 3 elements. That is, they are placed in between alkaline earth metals and the boron family, that is period, and they occupy period 4, 5, and 6 of the periodic table. Then below we have period 6 and 7 elements, which are called the lanthanides and the actinides element. They are basically called F block elements, and these elements are equally known as what? Inner transition series, or we can call them rare earth metals. We shall see in the periodic table template these elements and we'll discuss them better there. Elements of group 1 to 3, for example, we have sodium in group 1, magnesium in group 2, aluminum in group 3. They show metallic character by ionizing with electron loss, but the metallic character gradually reduces or decreases in the direction from sodium to aluminum. What do you mean by ionizing? They are metals, they lose electrons. Like now, sodium has 11 electrons with 1 electron in its outermost shell, and this 1 electron can easily be given out in the course of what? Chemical combination. That is ionization, loss of electron to become ion. Magnesium also can give out electron, and aluminum also can give out electron and become positively charged. So this ability will decrease as we move from left hand side to the right hand side on the periodic table. From group 4 to 7, which exhibit non-metallic character, as we are going to see in the table, the next slides. There are some elements that occur at the boundary line, and they are known as metalloids. Yes, particularly silicon, arsenic, and the antimony. Silicon, arsenic, and antimony, they are called metalloids because they exhibit properties partially of a metal and that of what? Partially as non-metal. They have dual attributes of that of metal and that of non-metals. Periods of the periodic table. There are 7 periods of the periodic table. The period is the horizontal arrangement of elements in the table. Each element in a period has the same number of electron shell, meaning elements are placed in the same period because they have the same number of electron shells. Now you see, example, we have period 2 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. They have the following numbers of electrons in increasing order of their atomic number. They are placed there because they have the same number of shells. Lithium has 2 shells, beryllium has 2 shells, boron has 2 shells, like that in that order. But the atomic number increases, that is, the number of electrons increases in this order, as we have earlier studied that elements are arranged in the periodic table in increasing order of their atomic number. This period corresponds to the number of shells, which we normally call K shell, L shell, M shell. So since we have 7 periods, then it means we have K shell, L shell, M shell, N shell, P, O, and the Q shell. That constitute 7 shells of these elements. Now this is a periodic table template, a table consisting of elements arranged in the horizontal rows called periods, and in vertical columns called what? Groups. You can see the first period consists of 2 elements, hydrogen and helium. I have the second period consisting of lithium down to neon, like that. I have period 1, period 2, period 3, period 4, period 5, period 6, period 7. Period 6 and 7 consist of lanthanized and the what? Actinized element. Remember, lanthanized element starts from cerium to the last one, the lutetium. Then the actinized start from thorium to the last one, lawrencium. These are cut out from this transition element because they are inner transition element. They occupy F block of the transition series, and that is why they are brought down and they are what? F block element. All other ones between group 2 and group 3 are what? Are the D block elements. Remember, these elements that are placed here, we have the same number of what? Valence electrons, meaning they have valence electron of 1 1. Beryllium, magnesium to radon, they have valence to radium, they have valence electrons of what? 2 2. Boron, down to the last element, they have valence electron of what? 3 3. Down to the last group, which is noble gases, they have valence of electron of, particularly helium has valence electron of 2. Then neon, down to the last one, they have valence electrons of what? 8, because they attain octet configuration. Now these elements, the elements in periodic table, they exhibit properties, and these properties vary at regular interval as we move from left hand side to the right hand side of the table, and also as we move from the top of the table to the bottom of the table. And the fundamental properties of this element, which vary periodically down the group and across the period, are as follows. We have atomic radius, we have ionic radius, we have ionization energy, we have electron affinity, we have electronegativity. Now, these are the properties that these elements exhibits in the table. This element will be exhibiting this property, and these properties will be changing or will vary at regular intervals as we move from left hand side of the table to the right hand side, and as we move from top to the bottom. And this brings us to the term called periodicity. What is periodicity? You can define periodicity as the variation of the properties of the element which is occurring at regular interval, both down the group and across the period. Here you can see periodicity is a variation of the above properties down the group and across the period. So let's take number 1. The first property is what? Atomic radius. What is atomic radius? This is half the distance between the nuclei of 2 covalently bonded identical atoms. It is also a measure of the size of the atom. Atomic radius measures the size of the atom. And what happens to the size of the atom as you move from left hand side of the table to the right hand side, that is across the period, and as you move from top to the bottom, that is down the group. We shall discuss that, and that tells us the periodicity of the property atomic radius. Now, 2 factors determine the radius of the atom. 1, the attraction of the positively charged nucleus for the electron. Number 2, the screening effect, which you can also call the shielding effect of the outer electron from the nucleus by those electrons in the inner shell. Now you will recall as you move from left hand side of the table to the right hand side, electrons are being added. Since we say electron elements are arranged in increasing order of what? Of atomic number in the periodic table. So as you are adding electrons, as you move from left hand side to right hand side, you are equally adding the proton in the nucleus of the atom of that element. Remember, we did say that the number of proton in the atom of the element is the atomic number. So as you are moving from left hand side, the atomic number increases, so the number of proton in the nucleus of each atom also increases. And remember, the proton in the nucleus is positively charged, whereas electron you are adding is what? Negatively charged. So there exists attraction, that is a pull that the nucleus will what? Exert on the external electron. You understand? So this attraction is what we call effective nuclear charge. Then also this second factor, screening effect, or you can call it shielding effect, depending on the number of inner shells or the shells before the outermost shell, that determines how this pull that the nucleus will exert on the external electron will be what? Will be felt. The more the inner shell, the lesser the effect of the nuclear charge on the external electron. So with this now, you can conveniently state how the size of the atom is changing as you move from left hand side to right hand side. Remember, as you are moving from left hand side to right hand side, there's an increase in what? Effective nuclear charge, because there's increase in the number of electrons as well as number of protons. So there will be more pull as you move from left hand side to right hand side, and that decreases the size of the atom as we move from left hand side to the right hand side. Then what happened to down the group? Down the group, there is an increase in the number of electron shell. So if you look at, for example, group 1, we have lithium, we have hydrogen, lithium, we have sodium, we have potassium. As you are moving, the number of shell is increasing. The first element there, hydrogen, is having 1 shell, followed by lithium with what? 2 shells, followed by sodium with 3 shells. So as the number of shells is increasing, the size of the atom is increasing. So, and that is why we are having increase in the atomic radius as we move from what? From top to the what? To the bottom, that is down the group. Now we have ionic radius. This is a measure of the space occupied by an ion in any direction of an ionic solid. When a metal loses an electron, a positive ion is formed, and the whole outer shell is what? Is removed. For example, sodium has 3 shells. The last shell is having 1 electron, which has a very low ionization energy and can be easily removed. So as soon as this electron is removed, the shell of sodium becomes what? 2. So as you are moving from left hand side to right hand side, the first element like sodium followed by magnesium, they show readiness with which they release their electrons, and they can easily release their last shell. Therefore, their sizes will be what? Decrease, because the number of electrons, as they lose electron, the number of electrons will be what? Decrease compared to the number of proton in the nucleus. So it means there will be more proton compared to the electron. As such, proton will pull easily the electron, outer electron, to itself. As such, you discover that there is decrease in the size. There will be decrease in the ionic radius as we move from the first group, second group, and the third group across the period. But when we reach the non-metallic side, you discover they are gaining electrons instead. That is from group 5, 6, 7. They are gaining electrons. So therefore, there will be what? There will be there will be increase in their size, because at that point they are gaining electron. The number of electrons will become equal to the number of what? Proton, and even more as you move further. So as such, the effect of the nuclear charge will not be felt much, because the size of the atom will increase. will be increased. So as such, one can say at ionic radius increases among the cationic, among the group 1 to 3 elements, and then increases from what, group 5 to group 7. But also down the group, the ionic radius will increase due to the number of due to increase in the number of shell. Now ionization energy has next property of element that shows periodicity. Now ionization occur when when an electron is removed from an atom, or an electron is gained by an atom. Now, for example, if sodium atom loses an electron, it becomes sodium ion, carrying what? A positive charge, that is +1. Then if a chlorine gains an electron, it will carry a charge, a minus charge. It means it has acquired an electron. And by the time they acquire or lose electrons, they become an ion. And that is what we mean by ionization. Now, ionization energy is the amount of energy required to remove an electron completely from a gaseous atom to form an ion. So it is expressed in kilojoule of the energy per mole of the atom ionized. So the greater the ionization energy, the more difficult it is to remove an electron from the atom. And the lesser the ionization energy, the easier electron can be removed from the atom of that particular element. Now, what happens as you move down the group? There's an increase in the size of the atom, and as such, the external electron is going farther away from the nucleus. Like the first atom in group 1, for example, hydrogen, is having one shell, which is the electron in that hydrogen atom is very close to the nucleus. So to remove electron from hydrogen atom is very, very difficult. But when you move to the next one, that is lithium, there is 2 shells in the lithium atom. So the inner shell will a bit cover the outer shell from feeling the impact of the nuclear charge. So you can remove electron more readily as compared to hydrogen atom. Then when you go to the third atom in that group, that is sodium, has how many shells? They have 3 shells. So the inner 2 shells will cover the external shell from effect of the nuclear charge. So you can remove electron there. The energy required to remove electron in the atom shell is reduced compared to the previous atom. So as you can see, since there's an increase in the number of shells to go down the group, so there is decrease in the ionization energy. But across the period, there is an increase ionization energy, because the size of the atom is decreasing as you move from left to the right hand side of the periodic table, that is across the period. So if the size is decreasing, it means as you are moving from left hand side to right hand side, the atom is becoming smaller and smaller, and the electron is getting closer and closer to the nucleus, which makes it more difficult to be removed as you move from left hand side to the right hand side. The atom with highest ionization energy in a particular group is the noble gases. In each period, noble gas will have the highest ionization energy because they have attained octet configuration, and as such you can hardly remove electron from the atom of noble gases. Then electron affinity. Electron affinity is a change in energy when 1 mole of electron is added to 1 mole of gaseous atom to form an ion. Now remember, ionization energy, like we have mentioned, is the energy required to remove an electron. Then in electron affinity is the energy that is released when an electron is added to the atom. So you can see electron affinity is like opposite of ionization energy. Now down the group, electron affinity increases because atoms with larger atomic radius tend to have weaker attraction for electron, and so form negative ion less easily. But across the period, electron affinity decreases from left to right. Electronegativity as the next property will show periodicity. Electronegativity is the ability of an atom to attract electron towards itself. Non-metallic elements which can attract electrons easily have high electronegativity value, but metals who loses electron easily have very low electronegativity value. Remember, when you move from group 1, group 2 to group 3, they show readiness with which they release electron. So we don't talk about attraction of electrons there, or rather, as you are moving from group 1, group 2, the tendency of releasing electron is decreasing in that manner until we enter the non-metallic side, that is from group 5 to group O. Remember, group 5 element will attract 3 electrons, will acquire 3 electrons. Then group 6 elements will attract 2 electrons. So as we are moving, the readiness with which these elements attract electrons is increasing, and that is why electronegativity value is increasing across, or increases across the period, until you reach group 7 element, that is the halogen. Halogen, that is fluorine in a particular period, or halogen in a particular period, will have the greatest electronegativity value because they show readiness with which they acquire 1 electron. Particularly fluorine is the most electronegative element as far as elements are in the periodic table. Now down the group, electronegativity decreases because the effect of the atomic radius is greater than that of the increased nuclear charge. So since the size of the atom is increasing down the group, since the size of the atom is decreasing down the group due to the increased number of shell, so it is very difficult for electron to be attracted towards the center or towards the nucleus, since the number of shells are increasing. So there are more shielding effect. The inner shells of the atoms of the element, as we are moving down the group, is increasing, so they cover the outer electron from being attracted into the nucleus. So down the group, you discover that electronegativity decreases, but across the period, electronegativity increases. So thank you for listening. We have come to the end of this class. We'll be meeting in the next class, where we'll be discussing the element, the halogens. So we'll be meeting in also the physical contact, where if you have any questions, you can ask. So thank you for listening.